Good morning. Today I am going to talk about supercapacitors initially. We have already discussed about supercapacitors. Just to summarize what we discussed in our previous lecture about supercapacitors, I briefly introduced what is supercapacitor and then what is the working principle of a supercapacitor, and then we discussed various types of supercapacitors and then the material what we use in supercapacitors. Of course, what we have seen that supercapacitor is basically a energy storage device which is having very high capacitance because of its construction, because of the way the device is prepared, and that actually gives a very high energy density. And then we have a high power density also, and therefore there are a lot of important applications of supercapacitor which I will just show after some time. But if we just summarize in a tabular form what we discussed about supercapacitors is the following. So, what we have seen is that supercapacitors are basically in terms of material, it can be divided into three types. The first one is the electric double layer capacitor or EDLC. Another is pseudo capacitors, and the third one is hybrid capacitors or supercapacitors. So, what are the basic difference in terms of the material used in three different types of supercapacitors? If we look at the EDLC or electric double layer capacitor, this is actually activated carbon, graphene and carbon nanotube. And we have discussed that what are the reason, how to what is the performance of one material as an electrode and then another material, and what are the advantages of different materials in that. Okay. So, basically when we discuss about supercapacitor, the thing which we always look at are the capacitance, ESR. Okay. These are the different values and the micropore sizes which sort of microscopically control the efficiency of this particular electrode material, and these are the things which we keep in our mind when we design a material for supercapacitor. Similarly, when we discussed the pseudo capacitors, I showed that we generally use metal oxide and conducting polymers. Okay. And what are the advantages, disadvantages, why we use that, those materials that we have discussed. When we talk about hybrid capacitor, generally there are three types. You can say the composite hybrid, asymmetric hybrid and battery type hybrids. So, broadly the classification of supercapacitor which we have discussed is this, and one very important component of the supercapacitors which I am just going to discuss here is electrolyte, because we know that the supercapacitor construction is that there are two electrodes and then there is a separator and then there is an electrolyte between them. So, let us look at the electrolyte in supercapacitor. So, let me again draw that. When we talk about supercapacitor, then we have something like this structure. So, these are actually the current collectors, and then we have a separator, we have a separator here, okay, and then we have one particular charge here. Suppose these are negative, and suppose they are positive, and in between we have electrolyte. So, we have electrolytes. So, there is a double layer formation as I discussed in the previous class. So, here we have positive, here we have negative, and these layers are formed in the interface. Okay. So, we have two double layer formation in the two electrodes, and we can write it as double layer formation. Okay. So, what is the role of electrolyte? Because electrolyte is a material which basically it gives a conducting path in the supercapacitor. Okay. So, typically people they use a organic electrolyte or the aqueous electrolyte, something like the H2SO4, KOH, etc. Okay, or say acetonitrile as electrolyte material. Okay, so now the question is, what are the important characteristics of an electrolyte that decide the overall performance of a supercapacitor? So, we have to always keep in our mind the basic characteristic of a supercapacitor, like whenever we design, we look forward, as I mentioned, the capacitance, we look forward ESR, okay, and then the cycle or lifetime, stability, okay. So, these are few important aspects which we look for designing a very good supercapacitor, and electrolyte plays a very important role in that, because that as far as the ionic conduction is concerned or the diffusivity is concerned, okay, or the viscosity is concerned, they all decide a kind of environment for the charges to flow from one electrode to another electrode and make an efficient device. So, let us just see how one can control these particular quantities in a sort of tabular form. So, you can see that, as I mentioned, there are different physical quantities which control the action of a supercapacitor. So, the first thing is capacitance, and where does actually electrolyte is placed. So, if we talk about capacitance and then we try to see what is the role of electrolyte, what we need to check are the ion size, we need to check the matching between particle size and ion size, okay, or the pore diameter and the ion size, that is important. The second quantity is power density, okay. So, if we look at the power density, what we have to look at, what is the potential window, what is ionic conductivity, what is the ion electron material interaction. These are few important aspects which one needs to know. So, now third thing is the energy density, and for that we need to understand the electrochemical stability, concentration, etc. The fourth is ESR, where one is to take care of ionic conductivity, ionic mobility and viscosity. And then we have the thermal stability. This is a very important thing. So, we need to know what is the boiling point, what is the freezing point, what is the the salt solubility. And then finally, the cycle life, as I mentioned, we have to talk about stability, ion electrode material interaction. So, there are various physics aspect which is involved when we consider an electrolyte. However, I am not going to discuss very detailed about this. So, what the idea here is to give you a broad overview of what are the properties of a good electrolyte, or when we choose an electrolyte for best performing supercapacitor, what are the physical quantities that one needs to know, and accordingly we have to decide an optimum electrolyte. Okay. So, now we look at the applications of supercapacitors. So, I already mentioned that supercapacitors are being regularly used, and I have also shown some of the photographs of supercapacitors which looks like battery, but generally we do not use here. So, we are not aware about this, but there are many countries where people use supercapacitors in many applications. Okay. So, some of the applications are that people use in wind turbines, use mobile base station, use in electronic devices, and different industrial practices. Okay. Additionally, these are the what are the uses people have started with of the application of supercapacitor. Additionally, people also started using supercapacitors in UPS, different electric vehicles, and various power electronics applications. Okay. Recently, people use supercapacitor as energy storage device for voltage stability, renewable and hybrid energy storage, also to regulate the source and grid where supercapacitors are used. Okay. So, what we see that there are a lot of applications of supercapacitors, and one can know or read detail about how these supercapacitors are used in all these appliances. So, I just summarized some of the application, and beyond that there are a lot of application in the military side. So, there are several military applications of supercapacitor, be it in avionics, it may be in munitions, it is radio frequency communication, or in military vehicles, or in radars, or some emergency power. Okay. So, overall the supercapacitor is a device which finds in application because of very high energy density, high capacitance, it finds its wide application in different areas. All right. So, I think with this my discussion on supercapacitor is over, and we will start today or introduce today another interesting energy storage device, that is lithium ion battery. So, I already discussed about battery. So, we all know whenever we think about battery, immediately comes in our mind that there will be two electrodes, okay, and then there is a kind of charge flow, or what is called typically in the battery galvanic effect, which takes place, and then a kind of electrochemistry which is there along with the the electrolyte present in the battery. Okay, we can differentiate different batteries. So, this I have already discussed, and we know about the the basic principles of battery. But what is lithium ion battery? Lithium ion battery is a class of battery which has been discovered not long ago. There lithium ion battery people have started using for just for a few decades back, and lot of research going on in ion batteries, particularly lithium ion battery, sodium ion battery, etc. So, lithium ion battery is a battery where we we use lithium ion battery for different applications with an intention to have a high energy density and a physical process which works in lithium ion battery is intercalation. So far we have not discussed about intercalation process. So, in the typical batteries which I discussed before, there was nothing called intercalation process, but now what we will introduce in lithium ion battery in intercalation process. So, one particular element, that is lithium, which is very light element, is actually intercalated between the electrodes. Okay. So, they flow in between the electrodes through the electrolyte and gets intercalated in the electrodes, eventually giving rise to an electric power or the energy. So, this is the main idea of lithium ion battery, but before that let us just look at what are the the important devices surrounding us where lithium ion batteries are used. And probably we do not know, some people who are working with lithium ion battery, they know about it, but we know about these particular devices, be it a minibus, a camera, a GPS, a Bluetooth, a laptop, mobile, torchlight, toy helicopter, tablet PC. These are all the appliances which we use regularly and day to day use. Okay. And lithium ion battery is the energy supplier to all these appliances. This is a very interesting thing, that it is behind all these appliances because of certain properties. So, what are the properties? Generally they are much lighter than other type of rechargeable batteries. This is a very important thing, and therefore, for all portable electronic devices you can use lithium ion battery very conveniently. And of course, if you consider a lithium ion battery pack, they lose only about 5% of its charge per month. Okay. So, it holds charge for quite some time. Okay. So, therefore, you can use lithium ion battery for quite some time, and it is having high specific energy and high load capabilities within the cells which are used for lithium ion battery. An important thing is that it is having long cycle and extended shelf life. Okay. So, this actually gives an advantage of lithium ion battery, and also they are almost like maintenance free, and they can handle hundreds of charge discharge cycles. This is a very important thing in lithium ion battery, and then you can very conveniently use lithium ion battery for various the devices, portable devices and day to day appliances. Okay. So, it is having high capacity, low internal resistance, good coulombic efficiency. So, there are several the properties of lithium ion battery which keep it ahead of many other energy storage devices as far as very the important day to day electronic appliances are concerned. Okay. So, the issues for commercial use, that what we need to know is a phase transition, electrolytic decomposition, formation of an unstable solid electrolyte interface. These are few important aspects: volume expansion, anode surface reconstruction, and active material properties. Okay. So, in this lecture in lithium ion battery, after this working principle, our focus will be mainly the materials which we will discuss in detail used in the lithium ion battery and make it a very efficient energy device. But before we go to the working principle of lithium ion battery, let us just try to compare that where we are at this moment. Okay. What are the devices that we have discussed? All right. So, I already discussed the battery, we discussed capacitor, we discussed the supercapacitor, and again now lithium ion battery. So, let us look at in terms of the capacitor, supercapacitor and lithium ion battery some important characteristics. So, you can see there is a few parameters. The temperature range is an important parameter, because all working devices are they are active in a particular or typical temperature range. Okay. So, you can see that this is aluminum electrolyte capacitor, this is EDLC, this is for pseudo capacitor, and this is hybrid, and then this is lithium ion battery. So, if you look at the temperature range, their working temperature range is more or less same for all the devices. Okay. And then if we look at the maximum voltage of operation, capacitor is quite high, and then supercapacitors and lithium ion battery, they are almost similar range. So, when we talk about a lithium ion battery and we see a voltage operation range increased from 2 to 4 volt, it is remarkable achievement that we will see later. Now, if we consider the recharge cycle, okay, and 1000 is considered as K, then the definitely for electrolytic capacitor it is unlimited, and then the EDLC pseudo capacitors and hybrid, they are in 1000 and 100 K range, whereas lithium ion battery it is slightly less. So, I do not talk about capacitance, but now if we come to specific energy, then we can see the specific energies capacitor is quite low. It is slightly improved in case of different supercapacitors, but it is quite high in lithium ion battery. So, when we talk about the specific energy, this is basically 100, 200, 300 watt hour per kilogram for ion batteries, see lithium ion battery. And this is a reason why people are all, because of such high specific energy, the entire research focus and material development of lithium ion battery is one of the thirst area. Okay, so now if we consider specific power, definitely the electrolytic capacitor is higher, then the range of specific power is slightly less in case of supercapacitor, and it is less in case of lithium ion battery. And then if we look at the self discharge time for capacitor, it is very small in few days, and for supercapacitor it is few weeks. Hybrid capacitor one can have a longer self discharge time, but for lithium ion battery it is quite long, and efficiency for all these devices are almost in the same range, and working life at room temperature is capacitor is slightly higher, and then rest supercapacitor and lithium ion battery is of the order of 3 to 5 years. Okay. So, these are all important characteristics of a lithium ion battery and other energy devices. So, therefore, one has to choose very carefully for which device, which purpose, which particular, for which appliance and what purpose, which particular device, energy storage device is required. So, now let us try to understand what is the working principle of a lithium ion battery. So, just now I told you that there is a process called intercalation. Okay. So, intercalation is a process where you insert an atom, okay, or ion in between different layers of material. It is just insertion of an ion in between layers. So, what is the meaning of intercalation? So, I can have a layered structure, and there are different materials which are having layered structure. The most common material where layered structures are seen are graphite. So, I can have different layers. This is black, this is red, then I am having again black, again red, okay, and then I insert some foreign atoms inside it. So, suppose you consider these as a layered structure, suppose it is graphitic layer, and then you insert a lithium ion in that, okay, by intercalation process, and then I finish this layer. So, it is this same layer, of course, that I have a black one now. red one, and again I have the black one. Okay. So, this is the layers of the material, and this is the intercalating ion. So, if you look at in slightly basic the mechanism wise. So, I have say a particular two layered structure, and I have one say intercalating species A, and we are intercalating this inside this double layer. Okay. So, it may form in this manner. It can make these two layers negative, this is positive, or these two layers positive, and this becomes negative. Okay. The basic driving force is always the oxidation reduction of the layer and the atom. Okay. So, it is basically the electron exchange phenomena. So, whether we are looking at oxidation or we are looking at reduction, depending upon what the ionic state the intercalating atom is present. Okay. And this is the main or the most important physical process which is happening in the lithium ion battery. But when we talk about such intercalation, one essential requirement which we should always keep in our mind is strong bonding in intraplanar and weak bonding in interplanar. So, the material should be arranged in such a way that interplanar the atoms are strongly bonded, and interplanar they are weakly bonded, and this is an essential requirement or the physical requirement where these in the layer where you can see the intercalation process can take place. Okay. So, when people started working initially with the lithium ion battery, they found different material, layered material. One material, as I mentioned, the graphite, and later on people worked on graphene. Okay. However, apart from the graphite or graphene, people also looked at different sulfide. TiH2 is one particular example of the the layered structure where the intercalation process was seen at the in the beginning when people started working with lithium ion battery. Okay. So, if we the entire idea is that now I want to change my battery. What I want to do? I want to place an electrode in a manner that the electrode has the capability of accepting the intercalating species. Suppose you are lithium, be it the anode or the cathode, they are capable enough to to accept these intercalating atoms. So, this is the main thing, and there will be an electrolyte in between and a separator which actually facilitates this intercalation process or the flow of the ions, say lithium, and then the intercalation process takes place. So, this is the main thing. As there is a flow of ion, we know that there is a flow of electricity and the power will be or the electrical energy will be generated. Okay. So, now if we look at the construction of a lithium ion battery, it is very simple. You have actually, let me just draw it in this manner. Okay, something like this. Then I have so one is say positive, another is negative. So, there are two electrodes. This is one electrode, this is another electrode, and then we have connection outside, and then in between I have electrolyte. then I have a separator. So, alright, this is the construction of a lithium ion battery. So, if we look at the lithium ion battery, it is basically constructed with the following components. So, there are two electrodes, okay. There is an electrolyte in between and there is a separator. So, generally these two electrodes are such that they are having a good the efficiency of intercalation process. This is the requirement. And so, when we discussed about the material for say cathode and anode, we will look at what are the materials that can intercalate lithium very efficiently. Okay. So, depending upon that whether we are doing charging or discharging, the the lithium flow is either from positive to negative or from negative to positive. All right. So, let me just give you an example when we talk about the construction of a lithium ion battery. So, one example, let us consider the anode is graphite and cathode is suppose some lithium compound. So, one very popular compound is LiCO2. Okay. So, there are many other compounds that we will see, but LiCO2 is a cathode material which are being routinely used in lithium ion battery. So, this is a typical construction of a lithium ion battery. Now, let us discuss about working principle of a lithium ion battery. So, as I discussed about the construction of a lithium ion battery, that it is one anode, one cathode, electrolyte and separator. So, now how does it work? So, let us see. So, let us first look at the discharging of a lithium ion battery. So, this is the anode of lithium ion battery and this is the cathode. Okay. And now, let me draw the separator. The separator and then this is the electrolyte. So, during discharging, what happens that if I just consider a suppose an anode which is graphite, and as I mentioned that the intercalation process takes place in the graphitic plane. So, lithium is within the graphitic plane during intercalation, okay, and this when we just connect a load with it, when I connect a load with it, then what happened? The lithium from the anode, it goes towards cathode, okay. That is called de-intercalation process. So, lithium goes from anode towards cathode through the separator, and that is called de-intercalation process. So, as soon as we connect a load, the de-intercalation process starts, deintercalation process start, and along with that the electron flows in the outer circuit towards cathode. Okay. So, on the way from its journey from electron from anode to cathode to the outer circuit, it gives load. So, suppose we connect any device here, suppose instead of load, say if I just connect a small bulb here, then it will glow because it will get powered. Okay. So, this is the discharge process of LIB. So, what happens with lithium ion, that it starts from anode and by deintercalation it goes towards cathode through the separator, and then cathode, which is also a compound of lithium, it starts accepting the lithium ion. Okay. So, what happened when we charge it? So, it is same, the charging process, only here we connect a battery. Okay. So, we connect a battery and then the direction of lithium changes. So, now lithium goes from cathode to anode, all right, and then the path of electron also changes. Now, electron moves from cathode to anode. Okay. So, all right. So, this actually happens when we do the charging process. So, earlier I talked about discharging process, and now it is a charging process. In charging process, actually what happened, the electrostatic energy of the battery gets converted to the chemical energy of the lithium ion battery or the cell. Okay. And then again the discharging takes place. So, charging and discharging continues in lithium ion battery in one particular cycle, eventually delivering power to the load. Okay. So, now let us look at what is the typical characteristic, discharging characteristic of a lithium ion battery. So, if I just plot the voltage, okay, and the discharge capacity, okay, we start from a particular point. So, we can mark a point when there is no load connected. Okay. So, that is actually the open circuit voltage of a lithium ion battery, OCV, open circuit voltage. All right. This is actually the voltage difference between the between the two electrode, between anode and cathode. All right. So, this is the open circuit voltage, and then there is a drop in voltage which is called IR drop, which basically takes place because of all the resistances present in the lithium ion battery. Okay. And then there is a over potential here. Okay. So, now at this stage we connect the load. So, therefore, what happens, a de-intercalation process starts taking place from from anode to cathode. That means, lithium starts moving from anode to cathode through the separator, and then the potential which is required to start that electrochemical activity, that is called over potential, and then it goes through a plateau region. Because now this de-intercalation process starts, and then cathode is accepting the lithium ion by again intercalation process inside the cathode. Okay. So, I already mentioned that a typical cathode is, say, a lithium cobalt oxide, which is a typical cathode material, and graphite is a typical anode material. So, this, if I consider this as cathode and graphite as anode, then this lithium which starts from graphite, it goes towards LiCO02, that is cathode, and gets intercalated there. And over this time, there is a plateau. So, there is a flat voltage, and then once lithium reaches to cathode and further intercalation process is stopped, and the diffusion of lithium also gets restricted while passing through the electrolyte, from the electrolyte through the separator to the cathode also diminishes. Eventually, the voltage drops. Okay. So, you can see there is a drop in voltage. Okay. So, now again, if you have to charge, then plug it in to a socket, and then again the process starts. Okay. So, again the anode gets lithium ion from cathode by the intercalation process, and the cycle continues. All right. So, this is a way a lithium ion battery works, its charging cycle, discharging cycle, and the voltage and discharging capacity characteristics. Okay. So, now let us see what are the materials people have used so far in a lithium ion battery. Okay. So, this is a big journey. In the literature, if you go through, you will find that the intercalation process was discovered long back, almost in 1840s and 50s. People used to look at the intercalation process in some sulphide, some oxide, generally transition metal sulphide, but it did not get a very great potential or in the research until in 1950s, 1960s, when people realized that because of intercalation process in a particular material, one can change the optical and electronic properties of the material. Okay. So, then the work started with different, say, MS2 metal sulphide, oxide, these are the materials which were studied, and then people reported that there are a lot of change in the the different physical properties of this material because of intercalation of some smaller ions like lithium, sodium, etc. Okay. So, it started with this journey, and then it was thought that one can make a battery out of the material which goes through this intercalation process. So, a combination was made where people have chosen TiH2 as cathode and lithium itself as anode. Sulfides are good material, they are layered structure like TiS2. So, the intercalation probability is high. So, it can be used as cathode, and then they observed a the voltage generation or working principle of a lithium ion battery when it is put in an electrolyte which is also a lithium salt in dissolved condition, and then a separator. Okay? Exactly the structure which I have shown, and the voltage which they could able to generate is less than 2.5 volt in the lithium ion battery. Okay. So, then people started working with different layered structure, and they also realized that lithium as anode is not good because there are certain problems. There is something called dendritic issue which can lead to a short circuit. Okay. And then they one research area was going through that what is the best anode material that one can choose, and then people found this graphite could be the best material because it is also a layered structure and intercalation of lithium can be possible in graphitic layer. But regarding cathode, there was another thought was going on, because as I just mentioned, using this TiH2 as cathode, one can only see a kind of voltage which is less than 2.5 volt. So, if you have to enhance the voltage, what type of the material you need to choose, and what should be the design of the material. Okay. So, if we just go to very basic thing, and as I mentioned that it is basically a potential. So, if I draw a potential of anode here mu A and a potential here of cathode say mu C. So, this is anode, this is cathode, and say this is electrolyte. So, electrolyte has the lowest unoccupied molecular orbital that we had discussed before, and highest occupied molecular orbital. And then if we come to this point, this is actually the maximum voltage that you can generate. There is also the open circuit voltage. Okay. So, what is the criteria? The criteria is that these two energy levels which I indicated should be separated as much as possible, and if you can make this difference more, then one can generate higher maximum voltage in a lithium ion battery. So, there are two conditions. First condition is that what cathode requires? Cathode requires the stabilization of higher oxidation state with a lower lying energy band, and anode requires stabilization of a lower oxidation state with a higher lying energy band. So, these are the criteria for cathode and anode to be selected. Okay. So, we have to find a lower energy band for cathode and higher energy band for anode, as I have indicated in this figure. People started thinking about some material like oxide. So, as I mentioned that one particular oxide which was being investigated by Goodenow and his team is lithium cobalt oxide. So, why lithium cobalt oxide is better than the previous cathode like TiS2? So, if you look at the TiS2 here, this is the TiS2, and that this is the energy state H2 minus 3p, which is the energy state of lower energy state of cathode. But if I look at the energy scale, it is quite high here. Okay. So, similarly, if we look at the lower lying energy state of say oxide, say lithium cobalt oxide, it is here. Okay. So, if I make a difference here between the anode and cathode, I can have much higher voltage for lithium cobalt oxide. This is also a layered structure. Okay. So, this straightway shows a an indication that if we use lithium cobalt oxide as cathode, okay, then we can have a voltage which is approximately 4 volt even higher. Okay. So, the reason behind this is that, as I just now I mentioned, that we have lower lying energy bands for this oxide cathode material. So, you can look at some other oxide material also like NiO2, LiMnO2, etc., which are considered as an efficient oxide material for lithium ion battery. Okay. So, now there are certain issues with lithium cobalt oxide, although it shows a very good promise, but there are some stabilization issue of lithium cobalt oxide as cathode material. What people notice that there is a release of oxygen from lithium cobalt oxide because of some exothermic process. So, people started they increase the stability of this material by coating some other oxide like say aluminum oxide. Okay. And side by side people also started looking for other materials for lithium ion battery. So, Goodenow and his group has done an extensive research on these different materials which can be a potential material for for lithium ion battery. So, as I mentioned, the first one is lithium cobalt oxide, where a monovalent lithium and trivalent cobalt ions are are ordered in 1-1-1 plane of a typical rock salt structure. Okay. So, what they have found that for layered lithium cobalt oxide, the lithium in the octahedral side actually offered an increase in the cell voltage. Okay. But as I mentioned that there are some stability issue, then they started looking for other oxide like spinel oxide. This is LiMn2O4, which was also used, the people did extensive research on that, and in this case for spinel LiMn2O4, the lithium in the tetrahedral side actually offers higher voltage. Apart from these oxides, okay, people also investigated a new material which is known as polyanion, something like say LiX Fe2XO4. Okay. So, where X actually there is some sulfur, molybdenum, tungsten, etc., and various people started looking at that XO4 as a polyanion in different combination, and they have seen there is an increased stability along with maintaining a higher voltage. Okay. So, we will discuss in detail about this material again in the next class. So, let us look at what are the anode materials. So, as I already mentioned that the most popular anode material is the carbon material. There are different reasons. Carbon, one particular reason is that it is cost effective. You can find carbon in different allotropic form. You can have a very good conduction in the carbon, and also lithium transport in carbon. Okay. And one best arrangement of atoms in carbon is anyway graphitic, as I mentioned in my in the previous topic, that intercalation process, where you can see that how these the lithium are intercalated in the graphitic plane. One can see very good and easily the lithium insertion in the graphitic plane. So, therefore, graphite was used, and now also people use graphite in order to make a commercial lithium ion battery. Okay. So, again if we just look at the process which I discussed. So, you can see this is the anode, which is the graphitic plane, okay, and these are actually lithium ion, the red one, all right, and the blue one, the small one, these are all electrons, and this is one typical lithium iron phosphate or LFP, which is used as a cathode material. So, if you look at this is the discharging process where electron goes in the outer circuit delivering power to the load which is a bulb here, and then in the charging process electron goes in the opposite direction, that means cathode to anode. So, in the discharging process lithium goes along this direction from anode to cathode, and in the charging process lithium goes from cathode to anode as I mentioned, and a one complete cycle of the lithium ion battery takes place. Okay. So, so it is a good choice of material, but there was some problem related to graphite also to use as a anode. Okay. The reason is that there are some exfoliation process, and then power density also reduces eventually when we use graphite, and people started thinking about other material as anode. Okay. People have also looked for oxide material, okay, transition oxide like Fe3O4 as anode. Some the transition chalcogenides also like MOS2, COS2 etc., and also people started investigating carbide and nitride material for anode of a lithium ion battery. And then of course, a lot of research in recent past has taken place to use different nanomaterial as cathode and anode material of lithium ion battery. Okay. So, in the next class I will discuss in detail what are the other materials that people use as electrodes for lithium ion battery, and what are the implication or what are the importance of the nanomaterial in cathode as cathode and anode material for lithium ion battery. So, for now let us just summarize what we have discussed in today's lecture. So, we discussed a little bit about the what is the electrolytes in a supercapacitor, okay, what is the role of electrolyte in a supercapacitor, and then we have seen what are the applications of supercapacitor. Then we introduce lithium ion battery as another storage device which is very popular these days, and lot of research is going on and lot of applications. I have already shown some application, and later we will discuss in detail about the application. And then we introduced a physical process which is known as intercalation process, how different the ionic species like example lithium ion, it gets intercalated to different material, okay, or in the planes of the material. And then we discussed about construction of a lithium ion battery, okay, what are the components of a lithium ion battery and how a lithium ion battery works, that means what is the working principle of a lithium ion battery. And I just introduced the electrode material of lithium ion battery, which is important, some important cathode and anode material which I just mentioned, and in next class we will discuss in detail about different materials including nanomaterials used as cathode and anode in the lithium ion battery. Okay. Thank you.